Student, according to Above principle, we know that in the ground state of the atoms, the orbitals are filled in order of their increasing energies. So, electrons first occupy the lowest energy orbitals and then enter into the higher energy orbitals. Only after the lower energy orbitals are filled. Okay, so energy of a given orbital depends upon the effective nuclear charge, and different types of orbitals are affected to different extent. Thus, there is no single ordering of energies of orbital which will be universally correct for all atoms. So, the energies of the orbitals is extremely useful. So their order such as 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 4f, 5d, 6p, 7s. Okay, so according to above principle, we know that in the ground state of the atoms, the orbitals are filled in order of their increasing energies. Okay, in other words, electrons first occupy the lowest energy orbitals, then they enter into the higher energy orbitals. Clear? S, P, D, F are the orbitals. Okay, we know that. And maximum electron holding capacity in S orbital is 2. And maximum electron holding capacity in p orbital is 6, and maximum electron holding capacity in d orbital is 10, and in f orbital 14. So student, these are the maximum electron holding capacity of each orbitals. Okay, and according to above principle, we know that electrons are first filled lower energy levels such as 1 is, then they going through the higher energy levels. So their energy levels are 1 is, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and then 5f, 6d, 7p. Okay, and so on. These are the electronic configurations of each element. Okay, such as atomic number of sodium. We know that 11, and its shells, that means orbits, are in their first shell or K shell, number of electrons is 2, and in L shell 8, in M rest of the 1. So these are the electronic configuration of electrons according to orbits. Okay, and each orbit has 4 orbitals, that is S, P, D, F, and K shell also, L, M also, they have 4 orbitals. Okay, S, P, D, F. Okay, so in K shell, number of electron is 2, and 2 electrons will be in S orbital. Okay, because maximum electron holding capacity of S is 2, so we can put 2 electrons in S orbital. Okay, then in L shell, there is 8 electron. So its distribution will be S contain 2 electrons and P contain rest of the 6. Okay, so 1s2 and 2s2 2p6. Okay, and rest 1 electron will be go into S. So these are the number of shells, and this number we put here before the name of the orbitals. 1s2, 2s2, 2p6, 3s2. So electronic configuration of sodium will be 1s2, 2s2, 2p6, 3s2, sorry, 3s1. Here only one electron, so 3s1. Okay, student. Now for practice, suppose atomic number Mn 25. First, break its number of shells, that is KLM. So K shell contain 2, L contain 8, M contain also 8. Okay, 8, 10, 18. 18 and rest of the electron, and maximum electron holding capacity of K is 2 and L also 8, and M shell contain maximum 8 electron and N contain 18. N can be contain 18 electrons. This is maximum electron holding capacity of N. Okay, and maximum electron holding capacity of N is 8. Maximum electron holding capacity of L 8 and K shell 2. So these are the maximum electron holding capacity of each shell. Okay, so N shell contain 18 electron. 18. Okay, so rest of the 7 electron we can write here. Okay, now we put the electronic configuration such as Mn 25 contain 1s2, then 8 electron we can put here 2s2, 2p6. Okay, then 3s2, 3p6. Okay, then according to above principle, after 3p we put the electron in 4s. So s orbital contain 2 electrons. Okay, so we have to write here 4s2. After 4s, our shell orbital is 3d, and d shell contain maximum 10 electrons. So we put here our rest of the electron, that means 5 electrons. So 3d5. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Clear? Okay, student. Now we discuss exceptional, that is Cu, copper 29. There is an exceptional case in copper. So it's first we break the shells. So number of electrons are 2, 8, 8, N contain 11 electron. Okay. Now we write the electronic configuration of copper, in which exceptional also present here, that is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, then 1 2 3 in M shell contain 8 electron, so 3s2, 3p6. Then we put the 11 electron, first 4s2, then rest of the electron, that is 3d9. Okay, but student, here is an exceptional case. We don't write 4s2 3d9. Okay, we write 4s1 and 3d10. Okay, because the maximum electron holding capacity of d orbital is 10, we know that. So half filled and full filled shells will be more stable configuration for each of the element. So we put here s in s orbital 1 electron and we fulfill the maximum electron in d orbitals. This configuration is more stable than this. So we write the structure as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. Okay, this is an exceptional. For fulfill the d orbital, we put here only one electron, and d orbital fulfill their total electrons. Okay, now student, there is another exceptional such as chromium. Chromium contain 24 electrons. So in K, L, M, N, we break the electrons as 2, 8, 8, then here 6. Okay. So student, now we write the electronic configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Okay, but student, this configuration is not stable because half filled and full filled shell of d and f orbital is more stable configuration than this. So half filled of d orbitals are more stable. So we write here 4s1 and 3d5. d orbital contain 10 electrons. These are the maximum electron holding capacity of d orbitals. So it's half filled, that means it contains 5 electrons. So for this we write the electronic configuration or stable configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Okay student, this configuration is more stable than this. Okay, so stable configuration of d orbitals, we write here 4s1, that means we put one electron in s orbital and d orbital contain 5 electrons. This is the stable configuration than this. So we write the electronic configuration of chromium as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Clear? So, electronic configuration of copper and chromium both are exceptional. Okay, student?